Welcome to this afternoon session. My name is Christoph Strobl. I work for Pivotal as part of the Spring Data team, and I'm they're mainly responsible for the abstractions for MongoDB, Redis, the search engine in Solar, a little bit of JPA if I have to, and of course Spring Data Commons as the central library that we have. I also do KeyValue. I don't do the Cassandra stuff at the moment, but just to give you an impression. What we're gonna do within the next 50 minutes is basically walk through Redis, the data types Redis has, a little bit of setup of Redis, so there's different scenarios that you can run Redis in. And of course, we'll have a look at the Spring integration, especially the Spring Data one with Redis, and how we try to make your life as developers as easy as possible when interacting with Redis. Just for me, how many of you are using Redis already or are familiar with the Redis APIs? Okay, quite a few. I don't hope to bore you too much with the introduction. We'll get over it pretty fast and then come to the other stuff. So what is Redis actually? Redis is the remote directory server. That's what it's called by its creator, Salvatore Sanfilippo. He created it about 7 years ago with its first public release out of a need, because what he needed was a fast key value store that he could talk to over the internet, and that was completely under his control, if you will. So the main use case was initially to use it as a key value store. But Redis grew a little bit, and so we got, it was used as a cache. It's used for distributed logs. It's used for analytics, if you're into that, using some bitfield commands and hyperlog log. You can use it for queues. Of course, there's a dedicated project based on the Redis codebase, which is called ThisQueue. It's also maintained by Salvatore, but I haven't followed it too much, but it seemed a little bit abandoned. So, and one other use case is many people use Redis as a distributed session store. And to support all these use cases, Redis uses internally some kind of data structures. So we got lists, we got hashes, we got our sets, we got even sorted sets, and something called a hyperlog log structure. And hyperlog log is a pretty fast data structure for counting unique things. So if you want to know, as given the example, you have a site on the internet and you want to know how many people unique IPs hit your site per day, hyperlog log is a pretty fast way to just calculate that without having to just sum it up. So you just keep stuff adding there and it will count unique things. Pretty cool. Additionally, on top of that, Redis offers you pub/sub, publish-subscribe mechanisms. It allows you to execute Lua scripts on the server, and it has its own flavor of transactions. We'll get to that a little later. Okay, let's start with some basic Redis data types and the commands, as we just saw them. So let's start off with a string, or a key value in general. So it consists basically of a key and a value up there. And Redis doesn't really care what they're up to as long as they're binary. So you could use anything, a serialized Java object as a key or a serialized JSON. Redis doesn't really care about it, though it calls them strings. So, and you can basically go on and set the key with a value and, of course, obviously get it back with the get command. You can also get an existing value and set a new value within an atomic operation. And you could just go on and say, hey, I just want to set the value if the key didn't exist before, so this would be set an X. You can, of course, question how long a string is or a value is. You can append stuff to it, though I wouldn't recommend it if you have serialized JSON in there as a value. Then appending could be a little bit dangerous. But anyways, you can do it. You can get a range out of your value or set a range how you like. And there is a special case. In case the string you store as a value happens to be any number, might be a floating point number, Redis allows you to do numeric operations on it like increase, which will be increased by 1. Then you get the dedicated increase by command for non-floating point numbers, and increase by float if you want to add some floating point value to it. Of course, you can do the same with decreasing. Let's have a look at some lists. So the list data structure is pretty similar to the one we have in Java. So it allows you duplicate objects. You can just push it to one side, so left push for append it there, or pop it from there, just retrieve it and remove it, or right push and right pop it from there. You can ask how many elements are within my list with the len command. So you already recognize a pattern in there, so it's a list data structure. All the commands start with L. Pretty easy to remember. You can set stuff, you can get stuff at an index, you can set it at a specific position. Of course, you can retrieve ranges and you can remove stuff from there, just using an offset, how many items to remove from the list. So you use a negative offset to remove it from the right end and a positive offset from the beginning. Sets. Sets are, as well as lists, pretty similar to the stuff we have in Java. So no unique objects in there, no order for those sets. So we got sorted sets as well. And you can basically just add stuff there, and with pop will give you just any object from the set. You don't know which, but it will give you one. You can ask for all the elements within your set with the smembers command. You can ask how many items are actually in my set stored. This is scard. You can ask if a certain element is a member of the set with the isMember command. And of course, you can remove stuff from your list, because that poor guy just got shot by his son. So you better remove him from your set. So far to the sets, I mentioned already we got sorted sets, which have basically a score associated to each item within the set. So this allows you to bring in some kind of order while still having only unique items within the set. Those are called C sets, and of course, again, all the commands start with set. You can edit, you can get ranges out of the set, and for a reverse order, you just use setRefRange. So this is you already recognize there is a language pattern in Redis and the commands it uses. And you pretty much get a unique command for all the operations you want to do, instead of having overloads using different parameters. Of course, you can retrieve elements by their score, so then you just would go on use setRange by score, or the opposite, if you want to reverse it, setRefRange by score. You could use lexical ordering, which would then be called with a lex in between, so this would be setRange by lex whatever, and you could then still go on and use its score. So the names get pretty long at some point. So I didn't add them to the slide. Of course, you can ask how many elements are there, the scores. You can get the score of a single element, and of course, you can influence the score of an element by just set increase by and then just give it a number and increase the score, so you can influence the ordering within this set. And of course, you can again go on and just remove stuff from there. Okay, Redis also got hashes, and here we got Danaris. So this is a hash inside a hash structure, if you want to see it that way. And we got key value pairs in there. So this is Danaris Targaryen. She's a queen, obviously, and she has a dragon, or well, 3 dragons as a pet. Of course, you can set the key and value stuffs in there. So this would be the hset command, taking the key the hash is stored under, and then just having hash key and values in follow. You can get stuff. You can set multiple keys and values within the hash and get them back. Okay. Of course, you can ask for the length of the hash, remove stuff from there, get all the keys, get all the values, and just get everything that's stored in there. One more to go for now. Of course, there's others that I don't cover at this point, but this is a pretty nice data structure. It's been added. It's not really a data structure, but it's been added in the recent 3.2 version of Redis. So those are the Geo commands. And if we have a look at it, the Geo API doesn't really introduce a new data structure, but it rather reuses a sorted set for storing the information. So what it does, it goes on and takes the longitude and latitude pairs and converts them into a score by using the longitude for the even bits and the latitude for the odd bits. So the resulting is a 64-bit integer that goes into the score, and later on you can then just do some intersection on that. I always get this terrible headache when I think about it, but it's pretty fast and it works really well. One thing to mention is that there is a little bit of an approximation there. So once you store something in the geostructure and retrieve it back again, the longitude and latitude pairs won't be exactly the same. So there is I think, they might vary by 30 centimeters or so. Okay, let's have a look at it. What it looks like. So this is just GeoAdd, as we would expect. You give it a name and the pairs, and then just throw it into Redis. With GeoPosition, you get the pairs back. As I already mentioned, they won't be exactly the same as you put them into. You can ask for the distance between two known points within the structure, and it will give you the distance between those. You can ask for the geohash representation, which is the string representation of the longitude and latitude. And of course, you can ask for the georadius, which is you give it a point and the distance, which makes up basically a circle, and it will give you everything that's inside that circle. You could also use an existing member as the center point and just ask what's in the surrounding of given from this point. And of course, you can just remove stuff from there because King's Landing was pretty much destroyed. There is no dedicated command for that, so as you would expect, some georem command that isn't there, because yeah, I don't actually know, but Salvatore must have thought this is a C set under the hood, so we got crem already. Why introduce a new command? So you have to use crem to remove stuff from your geo stuff. Okay. And as I promised, we'll have a really short look at transactions within Redis. And this is basically, you start a transaction by issuing a multi-command, and every succeeding command you send after that basically gets queued on the server. So the answer to a set command won't be okay as you would expect to be, but it will be, hey, I just queued that stuff for execution later on. And the same applies to a get command. So if I set a key and get a key, those commands would be queued. And when I'm done with it, it basically I call execute, which will then go on and give me execute the stuff on the server, and then just return me a list of all the results for my queued commands. And why this works so fine is because Redis is single-threaded. So you queue that stuff up, and then Redis goes on and just blocks and executes all that in a row, and there is no other thread that could interfere with you. So this is how Redis handles transactions. Of course, you might want to just discard your stuff, and this obviously works by just issuing discard, and the stuff is gone. Okay, let's have a look at some typical Redis scenarios. The single node, HA for high availability, and the cluster that came with the 3.0 release of Redis. Easy. Single node Redis instance, just start playing around with it. That's what we're gonna do right now. You basically go to the Redis website, download that stuff. I hope you have a Linux system or so, because you gotta make it. There is a Windows port, but obviously it's pretty easy. Just issue make, I've done that already, and what you end up with is a Redis distribution compiled on your computer. There is a source directory, and there is the Redis server command that you can start. It will just spin up Redis. There is a 3.2.1. There's a more recent version out, but for now this will do. And along with the Redis server, you'll get the Redis CLI. Also in the source directory, just fire it up. It will connect automatically to the local host that you port that the server is running. And then you can just go on and play around with it and say set key 1, and this would be Java, and set key 2, and this would be 2Days, and this is fine. And then you can go on and get the key 1, or call get mget key 1, key 2, and you'll get Java2Days. Pretty easy to get started with Redis. You can interact pretty well. All the Java clients that are out there more or less emulate the behavior of the Redis CLI, so all the commands you'll find on the Redis homepage will be there in the Java world, and you just execute them by just passing in the exact same command arguments, and you're good to go. So far to Redis single node. Let's move on with the presentation. Great. Okay, so the problem with the single node, I guess everyone in this room knows the problem is, imagine you use it as a session store. Once that thing goes down, you're pretty much doomed. Your users won't be able to log on to your application anymore, and nor will they be able to use it anymore, because their session is basically gone. And this is something you don't want to have. So what you start doing is you just add replicas or slaves to your master. This is pretty easy. Just issue the according command that's documented, set up the slaves. Those will be normally in read-only mode. And once your master goes down, you can then just go on and read your existing data from these slaves. Of course, you won't be able to write anymore, but it's an improvement. New users won't get onto your system, but the existing ones just will keep on working as long as they don't modify data too much. But still, someone has to restart the server and replay all that stuff so that your application gets up and running again. And this is why something called the Sentinel was introduced. The Sentinel is a Redis server that's running in a specific mode. And those Sentinels go on and monitor your master and slave configuration. So the Sentinels, depending on their own configuration, check constantly, is the master still there? Is it alive? Once a Sentinel detects the master went down or is unavailable, they basically, a majority of those Sentinels agrees the master is actually down. And what they then do is they start a new master election and just promote one of the replicating slaves to a new master. So your application will fail for some time, but not for very long, and is able to recover again by just having a new master taking over the work. All the Java clients support this transparently, so it's pretty easy to get going with that. Once someone goes on and restarts the old master again, it will just rejoin, sync all the data, and serve as a slave, because there had been a new master elected already. So if you want to have high availability, this is one of the solutions you could use that you don't have to come up with yourself. And with Redis 3, something new came, and this was like the cluster stuff. And what cluster does, it doesn't have any dedicated sentinels, but all nodes of the cluster know each other more or less. And they talk to each other constantly. And what it also does, it partitions your data by default. So what does this mean? A cluster consists of 16,384 slots. A slot is a logical group for a set of keys. So once you add a key to Redis, the slot is calculated out of the key and is then basically assigned to a node. Each slot can have as many keys as possible. There is no limitation how many keys you store in one slot, but you have to make sure that the cluster, that all slots are served by your cluster. And there has to be, all these slots have to be covered all the times by at least one master. So if you forget to add a replica to one of your masters, and that one goes down and serves a certain slot range that is then not any longer served, your cluster state will be in failure and you won't be able to do anything with the cluster unless all slots are served again. Okay, let's have a quick look at the cluster setup. Cluster had been a little bit of a pain in the 3.0 version to set up. It was some Ruby script that you had to execute and you really had to know what you're doing. For a starting point with the 3.2 version, this got far easier. There is a create cluster directory in which you can just call the create cluster stuff. This is just a little helper for you to get going. It doesn't help you reading the documentation and understanding what you're doing if you want to run it in production, of course. But for starting and playing around and getting a feeling for Redis in cluster mode, this is just fine. And let's go on and just create a cluster by calling the create cluster start command, which just starts 6 nodes. This will be 3 masters, 3 slaves. And then we just create cluster, we issue the create command. That will now go on and use the master configuration, add a replica to each of the masters, and it does the slot assignment. So you can see here the first one is going to serve up to 5,000 and 10 and 16,000 slots. So all slots are covered. All I have to do is I have to accept the configuration and the cluster meet command and so on will be sent to the according nodes. And then I can just go on and use the Redis CLI we saw before with the -c flag for cluster and the -p for port, because it's obviously running on a different port, as you can see here, to just connect to the cluster. Nice, there we are. And then we can again go on and call set key 1, Java, and then set key 2. This would be Java2Days. There you go. Oops, redirected. So what you saw here is basically the slot assignment, because I was talking to the first node, which obviously served key 1, as I stated there, but the slot for key 2 wasn't served by the first node, but I got a redirection from Redis, because I was talking to node 1 and it told me, oh no, I don't serve that slot range, so please go ask node 3 in this case and just place your key over there. This is something the Java drivers handle pretty decently. So they do the slot calculation and then just pick the right node for you, and they can follow the redirects. Don't be afraid for infinite loops or something, because you could move the slots around. All the drivers have settings for a break. So the default is basically 5 hops. If you haven't reached the node after 5 hops or 5 redirects, then they will just give you an error and saying, hey, I couldn't find the node for the slot. Okay, so that worked pretty nicely. Let me just add my key foo. So that one actually is there. So what I could go on and do now is basically I could ask for all the keys. And oh, those are only 2. So we already added 3 keys to our cluster, but the keys command that I would expect to give me all the keys just gives me the keys for a single node. So you see, Redis doesn't handle that for you, and nor do the Java drivers. So you will only get the keys for a certain node, and all the commands will be executed on a certain node. And this goes even further when you think about having keys that are stored on the same node. You would want to get them like we did before with the mget command. So remember, the key 2 and my key are stored on the 3rd node. And once I try to retrieve those, though they are stored in the same node, I cannot execute that command, because it's a cross-slot command. So Redis allows you only the execution of commands for multiple keys that map to the same slot. And this is something, this is another thing you have to be aware of when dealing with Redis, because once you migrate from an existing application to a cluster, you might have used all those commands, and they will start to break once you run in cluster mode because of the automatic partitioning that is done by Redis. Okay. Moving on. And this is exactly the place where Spring Data Redis comes into play and what we try to achieve with the project. I mean, the project has been around for quite a while. So it was started by Kostin Liao, who's currently at Elastic, but he started the project quite a while ago. And to understand how it works, we have some building blocks. So there's a dedicated Redis template that is using a connection factory. So those of you who are familiar with the Spring Stack will probably know all the templating stuff, JMS template and JDBC template. So the template basically manages the resources and handles exceptions. And under the hood, it uses a connection factory that gives you the actual Redis connection or a clustered Redis connection that lets you interact with a cluster. As I mentioned, that Redis doesn't really care about what you store inside of it. There are several serializers that allow you to just convert your types into a binary format. So you could use a JDK serializer, plain string serializer. You could even use Jackson and configure it the way you want it to just put your stuff into Redis. And under the hood, underneath the connection and cluster connection, you're free to use the Redis drivers. Currently we support 4 drivers. 2 of those are unmaintained at the moment by their authors, so we are gonna drop the support for those 2 and concentrate our development on the remaining 2 drivers, which are Redis and Redis for the future development. Okay, so how do we actually handle the cluster stuff? So what we with Spring Data do is basically we try to take away a little bit of the pain when dealing with the cluster by just reverting the approach the drivers took. So we when you issue, for example, a keys command, we detect that this is a command that has to be run across the cluster, and we'll go to each and every node involved, asynchronously execute the keys command there, then just collect the results and give them back to you for as a result. And the same is true for mget commands exactly. So we'll pre-calculate the slots, find the nodes involved, and then just execute the commands. And as mget, for example, guarantees you an order, so the values will return in the same order as you requested the keys. We basically go on and just reorder the stuff so that we meet the Redis specification, and then just give that stuff back to you so that your application in first place doesn't break when upgrading to a cluster scenario. Of course, this comes at a price because there's all this pre-calculation and asynchronous stuff going on under the hood, and potentially some merging within your Java code that you would have to do manually anyways. And of course, we allow you to contact a single node by just hey, go to that node and just give me the keys from there. But by default, we'll just always talk to the cluster and do our best to just make it as easy for you and transparent as if you were interacting with a single node. Okay, let's have a quick look at that stuff. So what we got here is nothing more than a Spring test. Spring Boot test. We're connecting to the first cluster node. The rest is auto-detected. And we'll just go on and just collect all keys in the cluster, so those would be distributed, and we assert that the keys come back correctly. If I just Eclipse, don't let me down. Where is it? I'm IntelliJ user for a month now, but I don't dare to use IntelliJ already for demos, so still using Eclipse. Okay, so that worked pretty decent. And of course, you could go on and read all keys from a single node. So this would be just by calling the keys command and giving it a specific node. So there is an overload there. And this would just return me the keys that are stored at this node without going to all of the involved nodes. And of course, this is the cross-slot command for mget for key 1, key 2. That should also work out of the box without having anything to do further. Okay, that worked so far. Let's move on to something different. Exactly the object hash mapping, which we built support for in the last distribution of Spring Data Redis. So generally speaking, normally we live in a complex world and don't only normally store just a key and a value, but rather have to deal with objects like a person that consists of first name, last name, some ID, and all that stuff. So you can just go on and use Jackson to serialize that stuff. Nothing wrong with that. Pretty easy, pretty fast. Those of you who have been in this session before might have heard, 2 sessions before, is that Jackson's still way faster and the fastest serializer out there. So you could go on and do that. And what you can then do with your data is you can just get it. That's pretty much all you can do. You could try to use some append commands, string commands onto your value stored in there, but I wouldn't recommend doing that if you're dealing with JSON data and just add stuff at a certain position for updating your data. So you basically, if you want to issue an update, you just load all of the stuff back into memory, convert it, and just write it back. Another approach would be using a hash, a Redis hash, for storing your data. And in that case, you would just flatten out all your Java object into key value pairs using a dot annotation like up there for nested objects as we have on this side here. So pretty easy. You can do the same for lists, just using brackets and all that stuff. And what this opens up for you is just you can get all your data back and deserialize it by just using hgetAll, which just gives you everything. Or you could do something like a projection. You're just interested in ID and last name, so you just use the hget command and just get those values back. Or you could ask if a certain property exists within the hash, or whatever you want to do. You want to do partial update, just issue hset and then just go on and update that single property without having to reload that stuff and rewrite it back to your database. So this is just another approach that might be useful. Obviously, it's not useful for all the cases, but it's a different approach, and I think it's worth thinking about and being aware of that this is possible. Okay, so what we've done in Spring Data is we used, since we have the metadata of your domain types already at hand, we just go on and reuse that metadata for object hash mapping. And this is pretty easy. So all you have to basically use is the object hash mapper that comes with Spring Data Redis, and then you're basically good to go. So what we've got here is the person, which is John Snow. He's a man. He lives or used to live in Winterfell, which is an address, and then we just go on and set the hash with the hmset command and retrieve it back from Redis. So let me just quickly run that stuff. Seems to have worked. So this is the cluster. Let's move back here. This would be keys. And we got the key over here. And if I call hgetAll using the key, you can basically see that it's just stored inside of the hash. Works pretty fine, and it allows you to do something like data manipulation using the hset command, just using the key and manipulating the hash inside, and then just read it back as you wish. Let me just execute that one. Okay, worked pretty nicely. Okay, so now that we've finished one alternative data storage structure or mapping scenario, let's talk a little bit about secondary indexes. This is nothing really new. Those of you who are familiar with Cassandra will probably know those structures. So normally, imagine you've got a session store and the user, and you use the email address to find authenticate that stuff, and the user might have multiple sessions in your applications open, but every time registered with the same email address. So you might want to use the email address as a key to find this next to the session ID that's unique to your application for finding, let's say, that user with that email address is currently registered in those 3 applications with those sessions. Okay, that would be one scenario. So you would want to have a structure that tells you, that lets you search for the user's email address and all these sessions associated with that address. So given that example, you might just call, you could use a set as a data structure to hold basically all the keys within. So what you would go, if you want to have an index for a first name, you would just go on and create a first name, and for each first name that you encounter, you just add the key to the set so that you can keep track of the reference to the original one. So that's what a secondary index is about. You could, and this would be what it looks like. Of course, you could do the same for last name, and you now see you can basically intersect those 2 sets, and what you would get is basically a finder that says find by first name and last name, and you'd get the ID back, and you could use the sinter command for sets intersect to just retrieve the keys. Of course, you could create an OR query the same way by just using sunion, and you get everyone with last name Snow or John back from the index. Okay, let's have a quick look at how Spring Data supports you in using that. We've got the Spring Data repositories, so we've got those for JPA and MongoDB and all that stuff. And now we also got them for Redis. And what this allows you is basically to have those tiny little indexed annotations down there. Of course, you can have a programmatic setup as well, so you don't actually need them in your code if you don't want to, but it just fits nicely on this slide. And then you just go on and say, hey, this is a person repository, this is a CRUD repository, which is a Spring Data type, no implementation needed, and then just call save, give it the person, and just store it in there. And what this does is it uses the object hash mapper we saw before, creates a hash, and sets up the index structures for you, so that you can then go on and just do some partial updates on that object, which would call the hset method, and then, since this is not so trivial because we get indexes in there, it just detect, oh, there has been an index, I've got to update the index, otherwise I would get false search results. So it basically removes the existing value from the index and writes the new values, writes the key to the new index or the updated value. And this allows you to have the derived finders that we have offer with Spring Data, so you can just declare a method within the interface, and we'll look at the method name and derive the query for you. And once you invoke that stuff, we'll just go on and create the sinter command for you, and then just retrieve that stuff. It supports pagination to some degree, because Redis doesn't really offer you means to do that on the server side, but we basically can then skip through the results and just load the stuff you're interested in. Okay, quick demo before we have to end. Still got a few minutes. Okay, so what we got here is we got the repository I was talking about before. The person repository, we got the key value template down there, and the connection factory to just have the stuff. We set up the family Stark and add them, and then we can go on by the find by last name method, which just takes the last name of added and run that stuff, and it mustn't contain Jon Snow because he has a different last name, which obviously works. The same is, we could use the AND keyword, find by first name and last name. So this would be aria only. Should work as well. And of course, you could create the OR, so this would be Aria or John, which should give us both of them. Okay. Of course, you could create secondary indexes on nested properties. So if you have basically the address and you have indexed in there, it would go on and create an index for person.address.city, what have you, and you're able to query for those by find by address _.city, just to make it obvious that we're descending into a nested object. Should work as well. Okay, you can go on, issue the updates as I showed before by just adding a template update and create a new partial update. We'll just use the information from the domain model to detect which properties are involved, so we can do it for maps correctly, for lists, and also for generic properties down there. This will all work, and there's one more thing I wanted to show you. Two more things, actually, since we got a little bit time. This is something called the expiration events. So Redis allows you to subscribe to some key space events. So Redis will tell you once a key expires, and it will give you the exact key that expired, though you won't be able to retrieve any of the values stored there because it tells you after it deleted the key. So, you know, session 123 expired just now, but that's basically it. So, what we do is when you can set a time to live, basically. Always this with the time to live property, so that you tell Redis to expire stuff after some time and receive the key space event. And once we encounter that stuff and key space events are activated, so you got to opt into that stuff by just enable key space events on startup, for example. Then we'll just write a phantom key that will expire a few minutes after the original one expired. Of course, we'll propagate all the updates and so on and so forth to that phantom key. And once we receive the key space event, we can then go on, load the data from the phantom key, and promote that stuff as an Spring application event, so that you get informed not only that session 123 expired, but that had actually been the user with email address foobar, and he had this and that stored within the session. So it's pretty useful sometimes to just get that information, and we do that for you out of the box. And another thing is that to reduce the stuff that you have in your data, or reduce the data size, you can also store references to other objects. So you could say, you could go on to the children of, let's say, Edard, and annotate it with @reference, which will then go on and just store the key to the other object within the list, instead of duplicating all that data and propagating it into the hash originally. So this is what it looks like when you do it. So it just creates a list and then just points to the key of the referenced object. Okay. Few more minutes left. That's basically what the Redis repositories are doing. We are evolving those a little bit and try to make them faster and more efficient. Currently, they also don't use any of the transaction stuff, simply because once you run the stuff in cluster and don't pin your key to a specific node, then the data would basically get distributed across the cluster, and all the sinter commands and so on and so forth wouldn't work, nor would a Redis transaction work, because they also have to be bound to a single slot, so this wouldn't work. But we know it's an issue, and we're working on it, and we're well aware of it. Okay, so what's next? already showed you references and all that stuff. You could also add custom converters in there if you're familiar with MongoDB and all that stuff. You can just register a converter for address and just use arbitrary JSON stuff and store the address as a JSON string if you want to. The update mapper will also pick up that and allow you, and then just create a JSON for that if you use updates. You could use spell-based indexing, so you don't have to use any paths directly in there, but use a spell expression, and if the criteria matches the spell expression, you'll create an index for that. So now we are on the what's next section, because all the other stuff is already available. We saw the Geo Index stuff. We're gonna add it for the repository layer, and we are working hard on the reactive data access side. So for Geo Indexing, you just imagine having a geo-indexed annotation on a point. Of course, programmatic setup is possible as well. And this will just go on pretty quick and just use the geo-add stuff and throw it in there. And then you can use the derived find address location by near and give it a point in the distance, and it would just execute the according Redis georadius command with the point and the distance unit, and then just retrieve whatever comes back from there. Nice. And one thing that will be coming with the 2.0 release of Spring Data is reactive data access. This is a general topic because for the Spring ecosystem, because Spring 5 will ship with support for reactive using Project Reactor and reactive streams. And so will the data access layers, at least those where the drivers allow us to do so. So this would be in the initial version, it will be MongoDB, obviously, because they can offer a reactive driver. It will be Cassandra on top of the async driver. It will be Redis, because Redis, the driver, already offers a reactive streams-based driver as well. For JPA, I'm sorry, we can't do anything about it. So this just won't work and isn't defined as it. So this is how it might look like. We are pretty close to a first milestone for the 2.0 release of the Spring Data world. And what we're using is Project Reactor types as a return type. So this, if you see this mono, this is a reactor type, or flux down here. You can think of it, this would be an RxJava single, and that would be an observable, more or less, just a little bit advanced. Of course, once the M1 is out, please just give it a try. If you're not using Redis, just give MongoDB a try and give us feedback. How it felt using the Reactive API, we really appreciate it, and we'll take all the feedback into account before we actually release that stuff somewhere next year, maybe a few months after the official Spring 5 release. Okay, I guess I'm done for now. If you've got questions, feel free to ask. I'm around today, I'll fly out tomorrow already. Thanks for your time and enjoy the rest of the conference.